This is a video explaining how to do some of the 5.3 Aplia assignments. Start with number one here, the number of rows. So in all of these assignments, you're going to be doing stuff with truth tables. This first one, hopefully pretty simple, just is going to task you with employing a rule for figuring out the number of rows you need to put in any truth table that you're constructing. This is typically step one for any truth table construction. And that rule is you take 2 to n, where n is the number of unique simple statements that you have in any statement that you're evaluating. So if we've got one simple statement, 2 to the n is going to be 2. If you've got two simple statements, it's going to be 2 to the n, 2 squared, which would be 4, and then 8, 16, 32, 64, so on. All right, and so you sort of work that equation here, if you will, or formula, to figure out what needs to go in these slots. The completed truth tables assignment, just like every other one, they kind of graduate. They start out pretty simple, then they're going to get harder as you work your way through, harder in terms of complexity, how many sort of operators you need to work with, negation, that sort of business. But the standard will still apply in any of these situations. Like this one, they nicely give me the left side of the truth table already set up for me, which is nice. That means I don't have to do that work. And all I have to do then is just sort of move this stuff over. And they're only using one simple statement here. So I would just transfer the true for the j, true for j, true for j from this line. Same here with the false. I need to select the main operator or main operator column, I guess is what they'll call this. This is going to be the thing that you do last. In this case, it's the triple bar. That's the thing outside the parentheses. So I do this stuff first. This is a true, true for a disjunction, so that's true. This is a false, false for a disjunction, so that's false. And now I look at my triple bar as my final or main operator. So I'd be looking at this true on one side of the triple bar and this true as the value for the disjunction. That's the thing I want to look at. Don't look at the values for the j. The only thing that matters here is the value for the disjunction. So it's true, true. So that's true. And it's false, false. That's also true. Remember, the triple bar is like an equal sign. If the values are the same on both sides, then it's true. Also, don't forget to click in on some of the stuff. The proposition has how many unique statement letters. It just has one. Therefore, it's got 2 rows. That should be fairly obvious since they've got it set up for me. And this is if I need help remembering things. Okay. I'll look quickly at truth table 4 just to give you a sense of the complexity it's eventually going to get to. All right, so this one is a 3-letter one. So it's got 8 rows. They've nicely given me everything again. Just remember, transfer over all your stuff row by row for each of the letters and then work your way inside parentheses using negations first where appropriate inside the parentheses to eventually getting to your main operator, which in this case would be the conjunction. All right, tautology, self-contradictory statements, and contingent statements. This is a way to classify particular statements as being something that's always true when you set up the truth table, something that's always false when you set up the truth table, and something that's going to like move around. Sometimes it's true and sometimes it's false. It just depends on what the values for the simple statements are. So this one, pretty short here, I'm given a almost completely filled out truth table for this complicated claim here using K, L, and Z as my letters. What I then have to do is figure out the final value for the whole thing using this as my final main operator. That will take a little bit of work. I have to look at what's important here. So note, on one side of this conjunction, I'm going to have this as my value I need to look at. It's going to be the thing that happened last after I did the disjunction. So this is what I care about on one side. And on the other side, I'm looking at this. This is the sort of main operator, if you will, for this nested piece of the claim within the brackets. So I'm comparing this to get my value for the conjunction. So this would be a false. This would also be false, 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 false. Notice that in every case, there's at least one false value. And a conjunction is only true if they're both true. That's why these are all false. So if I'm looking at this, and I'm now noting, hey, every single one of my truth table rows was a false for the final value, that means this thing is self-contradictory, right? That's because it's false in every case, and that's the definition of a self-contradictory claim. It's one where it's always going to be false regardless of what the individual values happen to be. If it was always true, that'd be a tautology, and if it moved around, like sometimes it was true here and sometimes it was false, then it would be contingent. Classifying statements, this is going to be more of the same. Probably with something a little bit less complicated. Yep. So what I do, just fill out the truth table once again. True, 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 false, false, false. Flip the sign here. I need to work inside my parentheses. In this case, the most inside thing is going to be this negation applied to the G. So that becomes a false, this becomes a true. I'm flipping the values it's applied to. And now for this inside conjunction, I'm going to look at this value and this value. Only look at the negation, not the G, because it's been switched or simplified to this. So that's a true false, which is a false. This is a false true, which is also a false. And now I look at the final main operator in the main column, which is this conjunction, and I'm looking at this value and this value. So here I have true false, which is a false. Here I have false false, which is a false. So this proposition is self-contradictory because it's false in every case. This is the only column I need to look at to evaluate whether it's tautologous, self-contradictory, or contingent, and it's false in both of those cases. The other classification sets are going to be the same deal. They're just going to move up in complexity. Yeah, I mean, this one is, apologies, some of these are going to be a bit tedious. You've got to do a lot of transfer stuff over, but the point of it is that once you get comfortable with something like this, there's nothing that's going to surprise you in terms of the test or anything else that you do as the course moves along. So for this first one, I'm going to work line by line and just transfer over the values on the left into the truth table for the compound statement. Taking care to put in the values accurately. So here it's going to be true and true for R and false for D. So that's false, true, false, false, true. And after I've filled all this stuff in, I would opt to look for the main operator to know what I need to do last. In this case, I know it's the triple bar. That's the thing outside the brackets and parentheses. And it's, in this case, ooh, excuse me. I take that back. Good thing I double checked. It is not actually outside this final, I believe, set of brackets, or is it? Okay, let's double check. Bracket here, bracket there means it's enclosed within this. Bracket there means it's enclosed within that. There's not an additional set of brackets. Okay, so this is outside the set of brackets. Now I'm left with the decision of, is it this that's the final operator, or is it this? Now note, a negation is only going to apply what's to the right of it, and in this case this is to the right of it, but note these brackets break this thing off so it's its own contained unit. This negation would really only apply to this thing, and then the triple bar would be what I do last. The rule that if you have a compound statement that has both a negation and another operator outside of the parentheses and or brackets, it's always going to be the thing that's not the negation. It's going to be your main operator. So in this case I have both a negation and a triple bar outside of brackets and parentheses. Because I've got two things, a negation and something else, the negation will not be the main operator. Okay, so this is the main operator. That's the thing I want to do last. And the way I would then approach this then, you can go left to right, you can go right to left, it doesn't really matter. For consistency's sake, let's go left to right. I want to do inside parentheses first, work my way outside of brackets. So this is OVR, where both parts are true. That's a true. I'm now looking at a true or true for this conjunction inside of my brackets. I'm looking at this value and this value. That's a true. And then I'm going to do the negation applied to this as the last thing for the left side of my biconditional. So this true is going to get flipped to a false. Right, this is the last thing I would do here because it applies to this entire bracketed part. Okay, so the left side of my biconditional is now done. Moving to the right, inside my parentheses here, I've got a true and true for a conjunction. That's true. Okay, over here I've got a true and true. That's true. And for my final part to do for this bracketed set, it's the disjunction. And now I'm looking at this value for the conjunction and this value to get a true, excuse me, disjunction. And so finally I'm going to look at my triple bar, the last thing I would do for this particular row. I'd have a false value that I look at, and I'd have a true value that I look at. These are the things that I would ultimately care about. This is the right side of the biconditional simplified. This is the left side simplified or reduced. So because they have different signs, it's a false and a true, this biconditional would be false. And I would do that for every single line, every single row for this particular compound statement. And that'll give me, ultimately, then a way to assess whether it's going to be a tautology, well, it can't be a tautology at this point because one line's false, but it could be a self-contradictory claim, or it could be contingent, and that'll depend on what the rest of this looks like. The 10th exercise, comparing statements practice, I'm actually going to do in a separate video because it does take a little bit of time to walk through that, and I'm almost out of time in this one. So stay tuned for part 2 of the 5.3 assignment video.